Here's a reminder of what your page should be set up to take notes for this video. This is for 8-6, choosing a factoring method. So let's say that you are taking a test or you're completing an activity in class or outside of class, and you're given a polynomial to factor. Now you have all these different factoring methods to use, and we've covered 4 of them already in class. So which method do you use? How do you know which method is the best method to use? How do you know if you're applying it correctly? These are questions we're going to answer in this video. So you're really going to have to think to yourself, how do you choose the best factoring method? Some factoring methods can work for other ones, for other type of polynomials, but there's always the best factoring method, and I'm going to help you determine which one is the best one to use. Let's first discuss the 4 factoring methods. Before I begin writing anything up on the screen, I wanted to give you an opportunity to review your notes and rephrase the 4 factoring methods. I'm going to talk about each method real quickly and then give you an example and show you how to use it. And then we're going to go ahead and apply it to a few examples. Okay, the first factoring method we discussed was GCF. How do you factor a polynomial by GCF? And I gave you an example to use. I just came up with this one on the top of my head. So here I'm going to go ahead and review the different techniques we use to factor by GCF. We first identified the GCF, and in this case it's going to be 4. We have to first look at the numbers, then the variables, x. They both have an x in common, and they both have a y squared in common. So I'm going to divide both terms by the GCF, and then I'll write the GCF on the outside of my parentheses. So this one will be divided by that, and then the second one will be divided by the same GCF. So that goes on the outside of the parentheses, and then I'm going to reduce. That goes away and get 1. X squared over x is just x. Y to the third over y squared is just y. And then I have a minus there. 16 divided by 4 is 4. Right? And then x over x is 1, so they cancel. And then y squared over y squared is also 1. They cancel out. And this is our final answer. And it's fully factored. Notice there's no other GCF or greatest common factors there. The second method we learned was grouping, and for grouping you have to have 4 terms. So I gave you an example, x to the third minus 3x squared plus 9x minus 27. Here, when we learned about grouping, we did it when we learned about GCF, and that's because we're going to have to use GCF twice. So for the first 2 terms that we're going to group together, the GCF is x squared. So I'm going to take out an x squared, and we would have x minus 3 left. And then for the second 2 terms that I'm going to group together, the 9x minus 27, the GCF in this case will be 9. So I'll divide both by 9 and get a positive 9 and then an x minus 3. Notice whatever is inside the parentheses will remain the same. So my final answer is x minus 3 multiplied by x squared plus 9. Okay, this is all review of the 4 factoring methods. So those are the first 2 that we learned. Okay, the third method we learned was the x method, and I gave you an example of x squared plus 17x plus 72. So when you use the x method, what you add to goes up top, and that will be 17. What you multiply to would be the 72. And you would think of 2 factors that would add the 17 but multiply to 72. 9 and 8 work in this case. So our factored form would be 9 plus x plus 9 multiplied by x plus 8. And you have your factored trinomial. The final factoring method you learned was the big X method. And here I have an example for us. 6x squared plus 11x plus 3. What we add to goes up top, so it's very similar to the x method, right? What we add to and what we multiply to will be 6 times the 3, which would give us 18. And then 2 factors that would work would be 2 and 9. And we got to divide it by our leading coefficient of 6 and reduce if we can. So this one would reduce to 1/3, and this one would reduce to 3 all over 2. And then we write in our factored form, so we get 3x plus 1. And we get 2x plus 3. And this is our factored form of that polynomial. So this is a graphic organizer of all four methods that we learned, and we're going to have to use all four methods to factor a polynomial. Sometimes it will be just one method, or sometimes it'll be a combination of two methods. I don't think we're going to do any problems with the combination of three, but you might have to do one or two methods per example. When given a polynomial and asked to factor, there's a few steps you want to go through, and you'll be able to use one of the four methods or a combination of the four methods from the previous slide. So when you're factoring polynomial, the first thing, which is step one, you're going to check for the greatest common factor. And if you have a greatest common factor, that means that you're going to factor by GCF. So you're going to first look for the greatest common factor. Then you're going to do step two, and you're going to check for a pattern that fits the difference of two squares. Remember, if it's x squared minus y squared, that's the difference of two squares, and you can use the shortcut instead of having to use an x method to factor the difference of two squares. So you check for the greatest common factor, then you check to see if it's the difference of two squares. And then you go into step three. In step three, you're either going to end up factoring using the x method, or you'll have to factor something using the big X method. Remember, X method is when a is equal to 1, and the big X method is for when a is greater than 1. And then the final step, which is step 4, is kind of like a check step. You're just going to check for any more common factors. Notice we did that first, but you might have missed some, so you're going to check one last time. These are the 4 steps we're going to use to go through all of the examples for this video. Okay, here is our first problem, 8x to the 6th power y squared minus 18x squared y squared. We're going to factor it completely, and then you're going to check your work on your own. So for this example, remember step 1 from that previous slide, and I hope that you wrote it down. If you didn't, rewind and get that slide written down. Step 1 is to check for a GCF. So let's see if we have a GCF here. Looking at the both terms, we do have a GCF. Let's look at the numbers first. The numbers have a GCF of 2. Right? They don't have a 4 in common or a 6 in common. And then x squared, y squared. So I'm going to factor that out, and I get 2x squared, y squared, and this will give us 4x to the 4th, and then y squared. Remember, I'm dividing these by the GCF, and the next term would be minus 9, and then x squared, y squared would be gone. Step 2, we're supposed to check to see if we get a difference of two squares, and we're talking about the inside of the parentheses, and notice this is a difference of two squares. This can be split off to 2x squared times 2x squared, and 9 is 3 and 3. So if we factor this further, we're going to rewrite our GCF on the outside. So 2x squared y squared, and then inside the parentheses it becomes 2x squared plus 3 and 2x squared minus 3. That example used 2 factoring methods. The first factoring method that we used was GCF, so by GCF, and then we had to factor using the difference, and I'll just put DIFF for short, difference of two squares. Two squares. So we used 2 factoring methods in one, and we got our final factored form. We could have also used the X method on the parentheses, but it was a little bit more challenging. We just applied our shortcut, a difference of two squares. Now on your own, go ahead and multiply everything in the box together using the box method or the distributive property, and you should get this answer back. Okay, here's our next polynomial to factor, and go ahead and check your answer once we're done. Step 1 is always check for the GCF, and we have a GCF here. The GCF is going to be 4x. So we'll divide everything by 4x, and inside the parentheses we would have x squared plus 4x plus 4. And that's dividing every term here by 4x. And now we can factor what's on the inside using the x method. So plus goes up here, 4, multiply 4, 2 and 2. So inside the parentheses we have x plus 2 times x plus 2. And then on the outside we still have that GCF we need to write because that's going to be our fully factored answer. We could also write, it as 4x and x plus 2 to the squared power since we have 2x plus 2's. Both answers are acceptable. Notice we used 2 steps here. The first one was GCF. We had the factor by GCF. Write that down. Then we have to factor using the X method. Okay, let's think of those 4 steps again. We're going to have to first see if we can find a GCF. And there's no GCF between 3, 7, and 4. Or any X terms in common. Then we'll think of difference of 2 squares. Well, remember, difference of 2 squares is a binomial with subtraction in the middle. And they have to be perfect squares. And this is not a binomial, and there's no subtraction. So it's not a difference of 2 squares. Then we'll have to use the X method or the big X. Since a is greater than 1, we'll have to use the big X. Notice how I verbally thought out my process of how I was going to factor this polynomial. I really had to think of the 4 steps. I had to check it. I had to do GCF first, then check the difference of 2 squares, then use one of the other factoring methods. And just a side note, remember, 4 terms would mean I would factor by grouping. So here I get 7, then 3 times 4 would give me 12. 2 factors that would work would be 3 and 4, divided by your leading coefficient of 3. This one only reduces to 1 over 1, and so I get x plus 1 multiplied by 3x plus 4. And here's an example of where I only needed to use one factoring method to factor my polynomial. Go ahead and use the box method or distributive property to check your answer. So I'm doing a lot of examples for this video, and I have one last one to do with you, and then the last slide is going to give you just all the information that we went through today. So we're going to factor this polynomial completely, and you need to first check for the GCF. In this case, we do have a GCF. They both have an x squared in common. So I'll factor out an x squared, and I'll get x squared minus 1. And then I look to see inside the parentheses. It's a difference of 2 squares, so I'm going to factor it. And I get x plus 1 times x minus 1. So I used 2 factoring methods. I factored by GCF, and then I had to factor by difference of 2 squares. And I have my fully factored form of this answer. So go ahead and check your work. Okay, go ahead and write down all this information, and we're going to go ahead and go through it in class. This is just a recap of everything that was in the video. It tells you what methods you can use to factor polynomials, what happens when you look at any polynomial, what happens when you see a binomial, either inside parentheses. When you see a trinomial, you'll use the X method or the big X method. So write all that in there. And then also when you have 4 more terms, you're going to have to factor by grouping. So this actually is a recap of all of Chapter 8. And we'll be practicing this to start our final projects.